Changes in oxidation number during redox reaction. Don't forget that during the process of oxidation, a substance loses electrons. During the process of oxidation, a substance loses electrons and it is oxidized. It means that if a substance is oxidized, which means it loses electrons. On the other hand, during the process of reduction, a substance gains electrons. And as such, the oxidation number of that element is decreased. Sometimes it is somehow controversial. I think I've said that before. During the process of oxidation, a substance loses electrons and its oxidation number increases in the positive direction. That is to say, it has been oxidized. So if you had a statement that a substance has been oxidized, it means actually that that substance has lost electrons. The same way with reduction. If a substance is reduced, it means that it has gained electron. It's somehow controversial. Substance being reduced, that substance gain electron. A substance being oxidized, that substance lost electron. But just get it into your tick score that a substance being reduced means that it has gained electron, and X, in fact, the indicator there is monitor the changes in oxidation number. If you see a substance, remember, always start from the reactant, trace it to the product. If there is any change in the oxidation number of those species, mind you that it is either reduced or oxidized. So if you check it, as we are going to see now on the board, if you check it and you see that the oxidation number is increasing from the reactant to the product, is increasing, which means that substance that you have observed, its oxidation number increasing, is actually oxidized, which means it actually lost electron. The opposite is the case. If you see any reaction or any species that its oxidation number is decreasing, that one is reduced. It has gained electron. So oxidation number plays a major role. One, it is used to give the correct IUPAC name of a compound. It is used to determine actually which species is reduced or which species is oxidized in a redox reaction. And in addition to the importance of oxidation number, it also helps to find out if a given reaction is redox or not. Don't forget, not every reaction is redox. So we use oxidation number to know actually those ones that are redox reactions and those ones that are not redox reactions. Let us check example on the board. So from the example on the board, magnesium atom plus oxygen gas gives you magnesium oxide. If you watch from that example now, you will agree with me that magnesium changes from zero. Remember, when it is standing alone, it is zero oxidation number. We dealt with this thing on the onset of oxidation number. So magnesium now changing from 0 to plus 2. Plus 2 is oxidation number of your magnesium here. While oxygen changes from 0, here is 0. Magnesium here is 0. Oxygen here is 0. So magnesium here now is plus 2. Oxygen here is minus 2. So magnesium now changing from 0 to plus 2, while oxygen changing from 0 to minus 2. So 0 to plus 2 is an increase, while 0 to minus 2 is a decrease, which means magnesium atom has been oxidized to magnesium ion. Has been oxidized to magnesium ion. Remember, being oxidized means that it has lost electrons. Okay, oxygen is now reduced. Oxygen atom has been reduced to oxide ion. Oxide ion. Oxide ion has been reduced to oxide ion. Remember, decrease in oxidation number is a clear example of a reduction reaction. So, and the oxygen which has been oxidized to oxide ion means that oxygen has accepted two electrons. Don't forget, when you now apply a mathematical idea to this, you may get it wrong somehow because minus here means acceptance. Oxygen is zero and has been reduced to minus 2. This minus 2 means that oxygen, when we say something has been reduced, I said this earlier, it means that it hasn't gained electron. Something has been reduced means it has gained electron. Something has been oxidized means it has lost electron. So oxygen here has accepted 2 electrons. Plus minus 2 is acceptance. Like I have told you, non-metals are negatively charged because they are good acceptors of electrons, while metals are positively charged because they are good donors of what? Electrons. So that is a good example. Let me now give you another example. Okay, the second example now, hydrogen sulfide gas plus chlorine gas to give you hydrogen chloride gas and now sulfur atom. So if you watch carefully from that example now, you will see that sulfur changes from minus 2. Sulfur here, the number of sulfur here is minus 2. This one is 0 here. This one is minus 1 and this one is 0. So the oxidation number of sulfur has changed from minus 2 to what? 0, and of which is an increase. Minus 2 to 0 is an increase. While chlorine has changed from 0 to minus 1, which is a decrease. That is to say that sulfide ion is oxidized to sulfur atom. Sulfide ion is oxidized to sulfur atom, while chlorine has been reduced to chloride ion. So clearly, remember I said that oxidation number is used to determine whether a reaction is redox. So the first one now, since there are changes in the oxidation number of the respective species here, is a redox reaction. The same thing with this one is a redox reaction. But had it been there is no change in the oxidation number of the respective species, it is not redox. For example, had it been that magnesium changing from 0 to 0, oxygen changing from 0 to 0, this could not have been a redox reaction because changes in oxidation number determines redox reaction. So in as much as there are changes in oxidation number of the respective element reacting, this is a clear, these two examples are redox what? Reactions. They are examples of redox reaction, and so on and so forth. So please don't forget that a substance is oxidized when it has lost electron, and a substance is reduced when it has gained electron. Let us quickly test for oxidizing and reducing agent.